Hey, Houston, we've had a problem here.
Can say again, please.
Houston, we've had a problem.
Houston, we've had a problem. Arguably the most famous 5 words in the history of space exploration. The now infamous transmission by astronaut Jim Lovell marks what could have been the beginning of the end for the Apollo 13 mission and the crew members aboard. Thanks to successful cooperation and communication between the Houston ground station and the Apollo 13 crew members, they were able to return home safely. This story is now a feel-good story, and it also shows the importance of space communication. With that knowledge, it becomes even more critical to address the limitations of the space communication infrastructure as we know it today. Indeed, according to Universe Today, the current state of radio frequencies cannot handle or is reaching the limits of what it can do with regards to the amount of data that's being sent back to Earth. Scientists are currently exploring 2 ways to overhaul the current radio-based infrastructure. Option number 1 is to use lasers, but those have clear line-of-sight limitations. Option number 2 is to use cubesats, which have recently gained in popularity with the launch of Starlink. But a networked array of cubesats would not be effective in spacecomm, as cubesats have neither the power nor the reliability to be able to ensure good communication over the vast cosmic distances required. That actually leaves only one option that I didn't mention, as I wanted to keep it a surprise, and that's XCOM, otherwise known as X-ray communication. It is the most promising solution, as it's actually been implemented back in 2019 with NASA's Goddard Space Flight Center on a mission, and it showed very promising results. It has 2 clear advantages. Advantage number 1 is that it is a shorter wavelength, meaning that you can transmit more data in the same time period compared to radio-based alternatives, for example. Advantage number 2 is that it has higher penetration power through most surfaces, meaning that it is less disturbed by atmospheric events. So that's good, as it makes the signal clearer. There's still one big issue with XCOM though, and that is detection. But I propose to solve that with metamaterials. Metamaterials are a very specific type of nanomaterial organized down to the sub-wavelength. This allows for very unique properties with regards to the manipulation of the electromagnetic spectrum. And X-rays are just another wave on the electromagnetic spectrum, so you can manipulate them using metamaterials. Indeed, a study in 2019 published in the Nature journal showed that metamaterials show promise and are actually implementable in improving the imaging quality of X-rays by improving the spatial resolution of the detectors. So this was considered in terms of the medical field, but nobody really considered the potential applications that this could have in the XCOM field, and that's where I come in. I think that the use of metamaterials in X-ray communications could really bring it higher. I think that that is what separates X-ray communications from the rest. There's still one issue with metamaterials though. That one issue that still remains is production, or scalability in production. And to solve that problem, there's one fabrication technique that is particularly well suited for this application, and that is EBL, electron beam lithography, as it allows us to have metamaterials that are of decent size while maintaining high resolution. How does it do that? Well, EBL uses an electron beam to target a thin layer of material called a resist, and this resist changes properties when it is hit by the electron beam. Then, using a solvent, you can selectively remove certain areas of the resist, and that way you can create intricate patterns. It's almost like using a pen and a paper, and where you have your pen, or in this case the electron beam, is where you leave your pattern. I think that using metamaterials to revolutionize XCOMs and to use EBL to guarantee high fidelity of the metamaterials while also maintaining flexibility in terms of materials, ensuring scalability of this idea is crucial to revolutionizing the world of space communications. I'd like to thank you all for your time. I hope you learned something today, and please leave me a like and comment below if you like this video. Thanks a lot.